Hello. In the last sessions, we have studied about different number systems like binary number systems, octal number systems, hexadecimal number systems, decimal number systems, and so on. And you know how to convert between different number systems. Like you can convert from binary systems to decimal system, decimal to hexadecimal or octal, and so on. Today, we will study a bit of arithmetical operations using binary number systems. The binary addition and subtraction. We will be adding and subtracting binary numbers. And this is very important in computational operations. In computers, what we do is these binary numbers are added and subtracted, sometimes multiplied, and they are divided so that they make certain scientific logical operations. So this is very important. Let's start with binary addition. Binary addition. For every process, there are certain rules. For binary addition also, there are rules. And the rules are like this. When you want to add two zeros, the result will be a 0. When you add a 1 and a 0, the result will be 1. When you add a 0 and a 1, the result will be 1. But when you add two ones, the result will be 0 and it will have a carry, and the carry will be 1. There are situations where you need to add 3 ones, 1 plus 1 plus 1. And the result will be a 1 with a carry 1. So these are the general rules in the binary addition. Now let's start doing some examples. Let's start with a very simple addition. Example 1. Let's add 1 0 0 0 and 1 0. This is not 1000 plus 10. This is a binary number and this is another binary number whose values are different, and you know how to convert this binary number into decimal number. So from the rule, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus nothing is here, that can be treated as a 0, so 0 plus 0 is 0. Again, 1 plus 0 is 1. So the result is 1 0 1 0. Now let's check whether this is correct or not. For that purpose, we need to convert this binary number into a decimal number. We know that this is 2 raised to 0th position. This is 2 raised to 1. This is 2 square and this is 2 cube. So only 2 cube is relevant in the first number, so that this number is 8. And this is 2 raised to 1 is relevant here. Only 2 raised to 1 is relevant, so it is 2. So 8 plus 2 is 10. If the operation is correct, this 1010 should be equivalent to decimal 10. Let's check that. 2 raised to 0 is 0, which is absent. 2 raised to 1 is here, and 2 raised to 3 is here, which means this is 2 raised to 3 plus 0 plus 2 raised to 1 plus 0, which is 8 plus 2 equal to 10, which means our operation is correct. Now let's do some more examples. As a second example, let's add, say, 1 0 0 1 and 1 0 1 1. 1 plus 1 is a 0 with a carry 1. Again, 1 plus 1 is a 0 with a carry 1. Now at this position, it is 1 plus 0 and you get it as a 1. Now here it is 1 plus 1, which is a 0 with a carry 1, and that carry is getting added with an imaginary 0 here, and that is 1 plus 0 1. So the answer is 1 0 1 0 0. You can check it whether this is correct using the conversion from binary to decimal. I'm leaving that part with you. Now let's do another example, like say 1 1 1 plus 1 1 1. We know that 1 plus 1 is 0 with a carry 1. Again, we have 1 plus 1 is a 0 with a carry 1, but we have a carry 1 here from the previous operation, so that 1 should be written here. Then moving to the next position, we have 1 plus 1 is 0, but the carry from the previous operation should be written here, and 1 plus 1 has a carry 1. That 1 is written here as a sum of 1 plus an imaginary 0 here. So the answer is 1, 1, 1, 0. We have another example. Say 1, 1, 1, 1, 1, 1 plus say 1, 0, 1, 0, 0. So 1 plus 0 is 1, 1 plus 0 is 1. 1 plus 1 is a 0 with a carry 1, which makes a 1 plus 1 here, which makes a 0 here with a carry 1. We have 1 plus 1 plus 1, which gives a 1 here with a carry 1. And 1 plus 1 is 0 with a carry 1. And that 1, when added with an imaginary 0 here, becomes 1 here. So the answer is 1, 0, 1, 0, 0, 1, 1. Okay, now let's do a problem with a decimal place. Say 100.01 plus 111.11. We have 1 plus 1, a 0 with a carry 1. Again, 1 plus 1 is a 0 with a carry 1. Again, 1 plus 1 is a 0 with a carry 1, which makes a 1 plus 1 with a 0 and a carry 1. This makes 1 plus 1 plus 1 is 1 with a carry 1, which makes a 1 here. So the answer is after adding the decimal place, 1100.00. Let's conclude our discussion on the addition with a final example. 101.01 plus 110.10. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0 with a carry 1, which makes a 1 here. So this is your answer. So this is how we make binary addition. Now let's move on to the next topic, binary subtraction. Binary subtraction. In binary subtraction also we have certain rules. Let's write down the rules. The first rule is 0 minus 0 will give you a 0. 1 minus 0 will give you 1. 1 minus 1 will give you a 0. But if it is a 0 minus 1, that will be a 1 with a borrow 1 from the next place. And we have certain rules associated with this particular condition. I will explain that on the go. Let's do some examples. Say, example 1. Let's start by subtracting 100 from 110. So 110 minus 100. So 0 minus 0 is, we have 0. 1 minus 0 is 1. 1 minus 1 is 0. So the answer is 1, 0 or 0, 1, 0. It's quite simple. Now to another example. Say 1100 minus 1, 1. So we have 0 minus 1 here. 0 minus 1 will be a 1 with a borrow 1. But the next place is also a 0. You cannot borrow from a 0. You can borrow from a 1, the nearest one. So we are going to borrow from this place to this place, which makes this 1 a 0 and the 0 in between a 1. So this is what happens when you borrow from the next nearest one. That nearest one becomes 0 and all the zeros in between become 1. That is what happens when you borrow. So this becomes 1. Now this is a 1. 1 minus 1 is 0. Now it is 0 here because it's been borrowed by this 0. So 0 minus, there is nothing here. So 0 minus 0. is 0. 1 minus again 0 is 1. This is the answer. Let's do another example. Say 1 0 1 0 minus 1 1 1. This is 0 minus 1. As we know, 0 minus 1 will yield a 1 with a borrow. So the next nearest number is a 1. So we can borrow from here, which makes this member a 0. So in the next place, it is 0. 0 minus 1 is a 1 with a borrow from the next nearest 1. So we can borrow from here, which makes this member a 0 and the 0 in between a 1. Now this is 1. 1 minus 1 is 0 and 1 minus 0 is 1. This will be a answer. Now in question number 4, you can have say 1 1 0 0 minus 1 0 0 0. 0 minus 0 is 0, 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. This is quite simple. Now let's try doing a problem with a decimal place. Say 111.01 minus 100.10. This is problem 5. So 1 minus 0 is 1. 0 minus 1 is a 1 with a borrow from the next nearest neighbor, next nearest 1 neighbor, which makes that member a 0. So you have 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. And the decimal point is placed here. So this is the answer. Finally, let's do another problem. Say 1010.11 minus 110.01. So it is 1 minus 1 0, 1 minus 0 1, 0 minus 0 0, 1 minus 1 0, 0 minus 1 makes it a 1 with a borrow from the next nearest one, which makes that 1 a 0. So 0 minus 0 is 0 here. So this is how we do binary addition and binary subtraction.